This lesson is Unit 11, Lesson 5, Special Angles. We'll be covering pages 361, 363, and 364. You want to have your calculator. So next we're going to look at some coordinate points that lie on the unit circle using the Pythagorean theorem. We have two important right triangles, our 30, 60, 90 and our 45, 45, 90. Our first exercise, consider the 45, 45, 90 degree right triangle shown whose hypotenuse is equal to 1. Since this is an isosceles right triangle, the two equal sides are labeled x. Solve for x and place your answer in simplest radical form. Okay, so using Pythagorean theorem, x squared plus x squared is equal to the hypotenuse squared. 2x squared equals 1. Let's get x squared by itself. Divide by 2. And now we take the square root of each side. X equals, and it represents the length of a side of a triangle, so we could ignore the negative. So this is the square root of 1 is 1 over square root of 2. Now, this is equivalent to what's called, when we rationalize the denominator, this is an irrational number, the square root of 2. So to make this denominator rational, we would multiply by 1 in the form of square root of 2 over square root of 2, right? We'd have to multiply the whole fraction by 1 in the form of square root of 2 over square root of 2. In doing so, we get the square root of 2 over the square root of 4, and the square root of 4 is 2. So this is the value of x in what we call simplest radical form with a rational denominator. Next, let's look at our 30, 60, 90 degree right triangle. It's shown whose hypotenuse is 1. This triangle is half of an equilateral triangle, so what is the length of the shorter side? The shorter side is opposite the smaller angle, so it has to be half of 1. In that case, 1/2. Using the Pythagorean theorem, find the length of the longer side. I'm going to call this y. We could have used a or b. So 1/2 squared plus y squared equals 1 squared. That's 1/4. Plus y squared equals 1, subtract 1/4, y squared equals 1, subtract 1/4 is 3/4. And now when we square root each side, we get square root of 3, and the square root of 4 is 2. So square root of 3 over 2. So the length of this leg here, opposite the 60 degree angle, is square root of 3 over 2. And when we have our 45, 45, 90, each leg is square root of 2 over 2 in length. We have this trig table, all right, which goes like this. You want to draw a square root, and underneath the square root you want two lines, 0, 1, 2, 3, 4, and then 4, 3, 2, 1, 0. The top heading above the square root are angle measures of 0 degrees, 30, 45, 60, 90. And I know it's there, but still copy it down. And the left heading for our two lines underneath the square root are sine and then cosine. This is all over 2. So if we're asked for the cosine of 60 degrees, we go cosine of 60 degrees. Cosine would be this 1 over 2. Would equal 1 over 2. That's what cosine of 60 equals. Adjacent over hypotenuse, 1/2 over 1 is 1/2. Let's go on. So we're skipping page 362, going to page 363. finding exact values of trig functions for special angles outside quadrant 1. So our special angles are our 30, 45, 60 reference angles. So we'll either use our special right triangles, in that you would have to know that for our 30, 60, 90 degree right triangle, opposite the 30 is a half, opposite the 60 is square root of 3 over 2, and hypotenuse is 1. And for the 45, 45, 90, you would need to know that each leg is square root of 2 over 2, and hypotenuse is 1. So if you're asked for the cosine of 45 degrees, adjacent over hypotenuse, square root of 2 over 2 over 1 is square root of 2 over 2. Or we use the trig table, okay? And for that trig table, write down the square root of, I didn't leave myself enough room there. I'm going to put it down here. I wanted more room at the top. So we do 0, 1, 2, 3, 4, 4, 3, 2, 1, 0, all over 2. The left heading, sine, cosine. Don't switch this. Why do we want sine over cosine? Because that's tangent. Tangent's equal to sine over cosine. And our degree measure is 0, 30, 45, 60, 90. Equivalent radian measure, 0, pi over 6, pi over 4, pi over 3, and pi over 2. You need to know this for pre-calc honors next year. Okay, so we want to find the exact value of the cosine of 135 degrees. We are going to determine the quadrant and calculate the reference angle. So here we have drawn a 135 degree angle. Remember way back in lesson 1, the reference angle? The reference angle is the positive acute angle formed with this terminal ray and, in this case, the negative portion of the x-axis. This angle measured would be 180 minus 135, which is that 45 or 55? It's 45. Not sure. 180 subtract 135 is 45. And we're missing all the steps here. All right, sorry. So we have our reference angle of 45 degrees. All students take chemistry to see if the result is positive or negative. So let's say that the cosine of 135 degrees is going to equal, we are in quadrant 2, where cosine is negative. So it equals negative cosine of our reference angle. So we write, in this case, negative cosine of 45 degrees. Sorry, this is our reference angle, theta. I'll just leave it 45 degrees. Look at the trig table for the value. Cosine of 45 degrees is 2 over, square root of 2 over 2. So negative square root of 2 over 2 is our answer. Right, following these steps here. B, find the exact value of sine 300. 300 degree angle, draw that. What is the reference angle? The reference angle is 60 degrees. So their quadrant is 4, and our reference angle is 60 degrees. The sine in quadrant 4. All students take chemistry, right? So we're in quadrant 4 where the sign is going to be negative. So this would be equivalent to, so sine 300 is equal to negative sine 60. And now we look at our trig table. Sine of 60 degrees is square root of 3 over 2. So negative square root of 3 over 2. Determine each of the following exact values. Let's see, write the trig table. Square root of 0, 1, 2, 3, 4, 4, 3, 2, 1, 0. Sine, cosine, all over 2, and angle measured 0, 30, 45, 60, 90. I didn't leave enough room. Radian measure, pi over 6, pi over 4, pi over 3, pi over 2. The sine of 330 degrees, this is going to equal positive or negative sine of the reference angle. So a 330 degree angle, I draw a picture, and it ends up in quadrant 4 with a reference angle of 30 degrees. In quadrant 4, sine, S-I-N, is negative. So this is negative sine of 30 degrees. We look up at our trig table. Sine of 30 degrees is the square root of 1, which is 1 over 2. So negative 1/2. The sine of 240 degrees. 240 degree angle ends up in quadrant 3, where sine is negative. All students take chemistry. So this is going to equal negative sine of, we need the reference angle. 240 subtract 180 is 60. So 60 degrees is our reference angle. Look at the trig table. Sine of 60 degrees is square root of 3 over 2. So negative square root of 3 over 2. That's our answer there. The cosine of 7 pi over 4. Okay, so here if you want to convert to degree measure, we take our 7 pi over 4. We want degrees, so we multiply by 180 degrees over pi. 7 times 180 divided by 4, because the pi's divide right out, is 315 degrees. So cosine of 315 degrees, that's going to equal cosine of our reference angle. 315 degree angle ends up in quadrant 4. Cosine is positive in quadrant 4, and the reference angle is 45 degrees. Right? It's always formed with the terminal side and the portion of the x-axis. So it's equal to positive cosine of 45 degrees. Go to the trig table. 45 cosine, 45 is square root of 2 over 2. Square root of 2 over 2. And some more practice on page 364. Continuing with some more radian measures. All right. So the first thing we want to do here is let's write down our trig table. Square root of sine over cosine 0, 1, 2, 3, 4, 4, 4, 3, 2, 1, 0. 0 degrees, 30, 45, 60, 90. Cosine of 5 pi over 6. Again, if you want, convert to radians, convert to degrees. You know that's going to go in there, 3, so this is cosine of 150. 5 times 180 divided by 6. 150 degree angle. So cosine of 150 degrees is going to equal positive or negative cosine of reference angle. 150 degrees. Put us in quadrant 2, where cosine is negative. Reference angle, 30 degrees. 150 plus 30 more would bring us to 180. So negative cosine 30 degrees. 30 degrees cosine, square root of 3 over 2. The sine of 2 pi over 3, that's 60. So this is going to be equivalent to the sine of 120 degrees. Let's draw an angle. 120 degree angle would end up in quadrant 2, where sine is positive. So this is equal positive sine of reference angle is 60 degrees. Trick table, sine of 60, square root of 3 over 2. You're welcome to pause the video or stop the video and try the last 4 on your own. It's 30, so that's 210. Cosine of 210 degrees would be equivalent to positive negative cosine of the reference angle. 210 degree angle ends up in quadrant 3, where tangent is positive, so negative cosine of reference angle is 30 degrees. Negative cosine of 30, square root of 3 over 2. Sine of 5 pi over 6. That's the sine of 150, which is going to be equivalent positive negative sine of the reference angle. 150 degree angle ends up in quadrant 2, where sine is positive, and the reference angle is 30 degrees, and this positive sine 30 degrees. Looking up at our trick table, sine of 30, square root of 1, which is 1 over 2. Sine of 5 pi over 4, change that to degrees. Five times 180 divided by 4, 225. Can't see it now that the lights went out. 225. That's going to be equal to positive or negative sine of the reference angle. 225 degree angle. Drawing it, you end up in quadrant 3, where tangent is positive. So this is negative sine reference angle. 180 plus 45 brings us to 225. So negative sine of 45 degrees. Sine of 45 degrees, square root of 2 over 2. Our answer is negative square root of 2 over 2. And our last one, cosine of 11 pi over 6. That's 330 degrees. Cosine of 330 degrees is going to equal positive or negative cosine of the reference angle. So is it positive or negative? 330 degree angle, we end up in quadrant 4 where cosine is positive. So positive cosine and a reference angle of 30 degrees. Cosine of 30 degrees, square root of 3 over 2. Thank you for your attention.